Okay, so what I want to do now is talk a little bit about the periodic table. Uh, a, an image of a periodic table is shown here, and on this particular periodic table, we have listed all the elements that are known or have been created by us. Okay, um, so let's go over very quickly sort of the structure. In the periodic table, the reason it's called the periodic table is it has periods, we call periods in it. So going from left to right, these are the periods. And then in the vertical, right, in the vertical, we have groups or families. So the columns are known as groups or families. So we have periods, which go from left to right. And then we have, and so those we would think of them as rows, right? And then we have the columns, which are known as groups. And that goes in this direction. Now, I'm not going to say much about periodic law. That you can read in the book, and there are little bits and pieces I'll probably pull out of there. If you do the practice quizzes that are for each chapter, you'll find some questions in there based on periodic law. Um, but there won't be a lot of questions on that. But I would just read it. It's easy to read. Now, so that's why it says here read 4.5 to 4.6, and that's in the current edition, if I'm not mistaken. Now, the groups are also known as families, and if you read that section, one of the things you'll find out is that all the elements in a group behave similarly in chemical reactions. And so that's why we call them families. So like I have a bunch of kids. I won't give it away yet because that's one of the things I haven't said if I'm lying or not yet about. I have all my children have similar properties: brown hair, brown eyes. All of them are tall, actually, except for my daughter who got my genes. But all my boys got my wife's tall genes, and so anyways, groups or families, and then periods left to right. Now, when you look at the periodic table, you notice it's made up of all these little tiny boxes, right? And these little tiny boxes have important information in them. Not all of them have the name of the element, okay? So that's the element's name. This, number 19, is known as the atomic number. Okay, so now, remember we talked about the nucleus having protons, neutrons, and the outside part having electrons, right? Well, it's the number of protons. So 19 is the number of protons. So it's the charge, the positive, it represents the positive charge of the nucleus. K is the symbol. Okay, so let's practice real quick looking at some of these different elements. And we'll locate where they are, and then I'll sort of describe their position and maybe some other things about them. Okay, so there's Na. Na is sodium. And sodium is in group 1 in the third period. Okay, so what does that mean? Group 1. Now, in the older periodic tables, and really the periodic tables I like, it's written as that, but in more modern periodic tables, it's a 1 like that. So that's group 1 or group 1A. And then the third period, we go 1, 2, 3, and so that's where you find sodium. Now, I didn't explain what the last number in that box means yet, so let's go back up here because you can really see it better up in here. This 22.99. This is known as the atomic mass. And remember we talked earlier, I introduced the idea of an atomic mass unit. So an atom, okay, if you get a whole bunch of sodium atoms, I should say, their average mass would be 22.99 atomic mass units. So in general, although not always, right, you'll notice like hydrogen has a mass of 1.01 and it has an atomic number of 1. And that mass comes entirely on average from the 1 proton that you find in the nucleus. But notice what happens when you go to some of these larger ones, right? let's take nickel. We'll find nickel here. So nickel is in the transition elements. This is known as the transition elements. Okay, and it has an atomic number of 28. It has the symbol Ni, and it has an atomic mass, and this is the atomic mass that's down here, of 58.693. Now, if it was just protons, right, you'd expect it to be around 28, and you'd be right, that's what it would be if it was just protons. But remember, we said in the nucleus there's also neutrons. Okay, so we'll talk more about the details of this number because you'll notice it says 58.693. You would expect, because protons and neutrons have masses close to 1, I mean, why isn't that number closer to like 58 or 57, right, or 59 or something like that? And we'll talk about why that is later. Let's see if you can find, so that's nickel, right? So we found the name and the atomic number. Go ahead and see if you can find phosphorus and then Ta, and you tell me what that name actually is. All right, so there we go. So phosphorus is element number 15. It's here, right? So it's here. It's in the third period. And then in terms of groups, we can count 1, 2, and then 3 here, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's actually in group 15 in the modern periodic table nomenclature. I'll tell you some of the other group names in a little bit. And then this last one is tantalum. And it used to be different. It used to be tantalium or something like that. But it became tantalum. It must be easier to say or something. But that's element number 73. So it has 73 protons, 73 electrons, and it has an atomic mass of 180.947. Okay. So that's a little bit about the periodic table. Now there's a little bit more I want you to be able to know. So I'm going to go back up to this periodic table. But there's this thing called periodic law. And basically periodic law says the properties of elements repeat periodically. And so that's when I told you, right? Elements in a group, like group 1A or group 1, all have similar chemical properties. That's as a result, or is what one of the things that led to the idea of periodic law. All right. Now, some of the things I want you to be able to find and identify on a periodic table. I want you to be able to tell me which elements are metals. Okay, so what I'm going to do is I'm going to go up onto this periodic table. I'm going to highlight all the metals, and then I'm going to highlight the nonmetals, and what we also know is the semi-metals, or what is also known as the metalloids. So I'm going to roll back up here. I'm going to clear off some of this junk, okay, and then I'll go ahead and shade some of this in. All right, so there we have it. The yellows, these are metals, okay, and the blue are the nonmetals, and the green are what we call the semi-metals, and you can MSN, sorry. You can recognize the pattern. It's not as weird as it might seem initially. Oh, I forgot to color in helium as a nonmetal. What the pattern is basically this. Starting with boron, right, you can make a step all the way down like this. Now, I didn't include these last two because not like a lot of these, I mean, even these ones that are here, I put them in the metals, but these are man-made elements, and I don't know how much information they really know about them, but I colored it in and I didn't feel like erasing it again. So, and then the semi-metals are in green. This is where we get the semiconductors from, for like computer chips. Germanium and silicon, like the Silicon Valley, those are used a lot in semiconductors. But what do you notice about the periodic table, right? Very few semi-metals. They're between the metals and the non-metals. And the metals are the majority of the elements on the periodic table. Now, having said that, let's talk a little bit about the properties of metals and nonmetals. So some of the basic ideas are metals are good conductors of electricity and heat. So we're going to say M, right? Good conductors of electricity and heat. They're also both malleable and ductile. So malleable means that you can form it into thin metal sheets, okay, or thin sheets, and ductile means you can form wires out of it. And they're also shiny or lustrous, okay. They reflect light well, and that's in part due to their what we call electrons or their electronic structure. But those are the main properties of metals. Good conductors of electricity and heat. Malleable and ductile means you can form foil out of, like, for example, aluminum foil. Ductile, again, being formed into wires, and they're shiny. And then non-metals tend to be sort of not those properties. They're not good conductors of electricity and heat. They're not malleable. They're actually, many of them are brittle, okay, and they don't tend to be shiny. And the semi-metals are in between there somewhere. They have some properties of metals and some properties of non-metals. One of the things you'll notice is all these elements of the nonmetals are clustered in the top right-hand side of the periodic table, and that's not really accidental. That has to do with the way the electrons are arranged in those atoms. Okay, so a couple of things you need to know. So I've covered the metals, nonmetals. Metals, nonmetals, metalloids, right? And then I want you to know these particular groups or families. So the alkali metals and the alkaline earths. So I'm going to call this 1A and 2A. So 1A and 2A are actually groups 1 and 2. Like that. Those are Roman numerals 1 and 2. And those are known as the alkaline earth metals and the alkali metals. Okay, so group 1A is alkali metals, and then group 2A is the alkaline earth metals. Now, the noble gases, these are group 8A, or 18. That's the other number for it. So you can write it like this as well, and a lot of people prefer to write it as the number 8, but a lot of times you'll see it in the Roman numeral, right? So you should be able to recognize this as 8A. The noble gases get their name because they're very unreactive, and so they don't mingle like with the common elements. Let me write this here like this: 8A, and then 1A and 2A. Those are common abbreviations. And then there's the halogens. Okay, so that's 7A. In the Roman numerals, it's this. Okay. And the halogens are group 7A, and those are fluorine, chlorine, bromine, iodine, astatane, and I don't even know what that TS really is. I didn't bother even to read it. But those are one of the more recent man-made elements. In fact, I think of the list of elements, that's the one that was done most recently, like within the last 10 years. Anyways, let's see what else is there. Oh, yeah, so there's the main group elements. And those are groups, so get this, 1A through 8A. And I'm going to use orange for that, I guess. It's these groups here, and then all these groups here. Okay, so this is 1A, 2A, 3A, 4, 5, 6, 7, and 8A. Now, having said that, the reason they get their name is it's because they look like they should be next to each other. So they called those the main group elements. And these were known as the transition elements because it's the transitions from the two sides of the main group. So the transition, or sometimes transitional elements, these are often designated as the B elements. So these get numbers like, in fact, this is 1B and 2B and 3B, and I don't want to have to explain why that is at this point, but some date later, if you take one of my Chem 1A classes, for example, maybe I'll explain it to you then. It's just hard to go over right now. Okay, so, but 1A, 1B, 2B, and then 3, 4, and then a whole bunch of them are 8B in the middle, 4, 5, and then 8Bs. There's three of them. But we'll talk about that some other time, like if you take a more advanced chemistry class. But for now, that's part of the organization of the periodic table. So, the next thing we're going to be talking about is ions and how you make ions from atoms.